Battery. A great invention. Perhaps you heard of it. It powers basically everything. Smartphones, cars, whatever this thing is. But do you know where did they come from? How do they work or who was the guy behind them? Well, I already made a video, so you're watching it, even if you do know. So sit down and get ready to find out how. We're in Italy, late 1700s, and this is Luigi Galvani, an 18th century scientist, physician, philosopher, and apparently also a frog dissection enthusiast. Weird hobby, okay. Now, you have to understand that at the time, everyone was obsessed with static electricity. We had these fancy crank machines that made sparks and stuff. Basically, 18th century party tricks for people who didn't have Netflix yet. Scientists were also starting to believe that electricity might actually be the life force. You know, the thing that makes stuff alive. So, during one of Galvani's experiments, supposedly testing how muscles react to static shocks and opiates, don't ask, something weird happened. One of his assistants touched a frog's leg with a metal scalpel just when a nearby static electricity machine caused a small spark. The spark jumped through the air, aiming for the scalpel but going through the leg, causing the limb to kick. Galvani, now in full Eureka mode, concluded that the plucking must have been caused by some mysterious animal electricity. I know, but to be fair, it sounded pretty sciencey at the time. Little did he know, however, there was another man with entirely different theory. Alessandro Volta, also Italian, also a scientist, also, just like us, tired of people zapping frogs for fun. Volta was a professor of experimental physics at the University of Pavia, and unlike Galvani, he was a bit more sober-minded. He realized that the frog's leg twitching was not caused by some animal electricity, but instead by the nerve in the leg reacting to the electrical current flowing through it. A shocking discovery, indeed. To prove his point and to shut everyone up, Volta built a device that could produce electricity without any frogs involved, using metals and cloth instead. Very vegan. The result? The voltaic pile, the world's first battery, and basically the great granddaddy of the thing keeping your phone alive at 2%. Now, even though Volta technically invented the battery, he wasn't entirely sure how it worked. In fact, he added 2 extra electrodes, one at each end, because it looked cool or for whatever reason. Which is honestly kinda based if you ask me. Just slap some metals together, declare victory and figure out the science later. But don't worry, turns out it's actually pretty simple. The voltaic pile is made of multiple cells, each consisting of zinc and copper electrodes, sandwiching the electrolyte, usually a piece of cloth soaked in salty water, in between. The zinc part reacts with the electrolyte and oxidizes, meaning it loses 2 electrons. These electrons are left behind in the zinc metal, while the zinc positive ions wander off into the electrolyte to hang out and do absolutely nothing useful. Meanwhile, over at the copper end, the electrolyte is full of positive hydrogen ions wanting to become the real boys. I mean, the stable hydrogen atoms. They grab the electrons that travel through the copper from the zinc in the cell below, pair up, and form stable hydrogen gas, which then politely bubbles out of the system. The electrons which stayed in the most highest zinc electrode really want to travel towards a positive charge. When we then connect the highest zinc to the lowest copper with a wire, voila, we get a stable electric current. The more copper-zinc electrolyte sandwiches you stack, the bigger the voltage. When cells are stacked in a series, the electric fields from each one adds up, so the electrons in the upmost electrode feel much stronger total push, which means a higher overall voltage. At this point, you might be wondering, wait, why is the copper in there? It didn't do anything. And yeah, you'd be kinda right. It doesn't react, it's just along for the ride, acting as a conductor and a catalyst. It's like that one chill guy in a group project who doesn't do the research, but somehow makes everything work better. And yes, you can swap copper for another noble metallic conductor, like silver. Although silver's way too boogie for a scientific experiment, unless you're trying to flex on your colleagues. And Volta's invention wasn't just a party trick, it became a serious scientific tool. Early chemists used voltaic piles to discover new elements like sodium, potassium, and calcium, by zapping compounds until the pure elements showed up. Similar devices to the voltaic pile even powered early machines of the Industrial Revolution, before some nerd inverted dynamo. But wait, you ask, what about Galvani? Don't worry, he didn't exactly fade into obscurity. In fact, galvanization, the galvanic cell, and a bunch of other scientific terms proudly carry his name. And no, this isn't to mock him for his animal electricity idea, it's to highlight how important curiosity is. If Galvani hadn't made his grand conclusion, Volta might have never built the voltaic pile and the world might look very different today. Even mistakes can spark revolutions in science, which means, who knows, maybe one day even you could create something world changing. Oh, nah, I'm just kidding. You're completely useless.